Welcome to my final project. My project's title is called SKYWATCH v1.0. My name is Yasin Zair, and my GitHub is Yasojan, as well as my EDX username. My city is Los Angeles, and my country is United States of America. And I'm recording this as of February 20th, 2026, and it is a Friday evening. Okay, let's get right into it. With SKYWATCH, essentially what we're doing is getting the longitude and latitude from the user, and we're essentially trying to see if the flight conditions are favorable. Um, so, for example, if one was to want to see if the flight conditions are favorable in China Lake, California, they would input the longitude and latitude, and then the program would tell them whether or not the flight conditions are favorable or not, whether it's a go or a no-go, and we'll get into that shortly. So first, what we do is we hard code the longitude and latitude to units that are outside of the range of negative 180 and 180 and negative 90 and 90 respectively. So we set a while loop while the longitude is less than negative 180 or the longitude is greater than 180, meaning it is out of bounds. Then we continuously assign the variable longitude to the input, which should be a float of the longitude. We do the same for the latitude, and to let the user know that we've accepted this longitude and latitude values, we print SKYWATCH v1.0 again. And now we call our check weather function and we pass in the latitude and longitude arguments. So if you go here, you'll see a very long URL. And here in the open-meteo is a open source weather app where you do not need an API key and it is free of charge. You simply click through all of the variables you want to see and it generates a API URL for you. So we go ahead and enter that here. Notice that this is an F string where we have not hard-coded the latitude and longitude because these are user-generated values. And here are all our variables. We want the unit in Fahrenheit. So we get the response. Note that we're importing JSON and we're importing requests for this request. So we're setting the request.get and we're passing in the URL, and that is going to be our response variable. So now we are essentially going to return this JSON object. And now when we do that, we go back to our main program. We see that this JSON object is now in our main program data. That's the variable that we have assigned it to. So now we print the flight criteria and we pass in this JSON object, which we've called data. So if we go down to flight criteria, and this is just a helper function, by the way, if we go down to flight criteria, now we have that JSON object. We're calling it weather, just so everything is not too uniform and confusing. And we are hard coding data to be equal the local variable data is going to be the passed in JSON object, which is weather that we have called it here. We're setting warnings to 0. So now we are going to check the JSON object, and now within the data and the current dictionary, we're going to find temperature. And now if the temperature is greater than 105.0, it's a high density altitude. The plane won't lift well. Same with if it's less than 32 degrees, there's a risk of surface icing on the flight instruments. So that's another warning. Now, if the wind speed is greater than 25 knots, the wind speed is too high. There's structural limits for taxiing and takeoff. That's another warning. If the wind gusts are greater than 30 knots, the wind gusts are too strong, there's a high risk of loss of control on the runway. That's another warning. And now if the visibility is less than 3 miles, visibility is too low. Military visual flight rules, minimums. That's another warning. And now we return, and now we call our helper function output message, and we pass in the amount of warnings it's received. So now here's our helper function output message. We've thrown in the warnings, or rather passed it in as an argument, and now or as a parameter, and we're seeing if warnings is less than 0, we return error. That's a failed risk assessment. because there's no such thing as a negative warning. And now, if the warnings are greater than 0 and less than or equal to 2, that's a moderate risk. Access is still denied. If the warnings are greater than or equal to 3, that's a high risk. Access is denied. Otherwise, there's no risk, meaning the warning is at 0 and the access is granted. So this is our program, SKYWATCH version 1. Now moving on to testing it. Now we're going to import PyTest, and we're going to import requests again, and we're going to import all our functions from the project, and now we're going to call it in the main. Now our first function is test check weather. We're going to pass in a latitude that's out of bounds, and now we're going to assert that this is going to equal to the JSON object, which is an error, that it must be in the range of -90 to 90. Now we're going to do the same with the longitude. The latitude is in range, but the longitude is not. And now it's going to be, it must be in the range of -180 to 180. We're going to do the same with test the output message. So now if we put in -100 warnings, which is impossible, that's an error. It's a failed risk assessment. Something is broken in here. We're going to assert that if there is a 0 warning in our output message, that's no risk, access granted. Otherwise, if there's 2 warnings, it's a moderate risk. If there's 4, it's a high risk. So you see the pattern here. We're going to call our test flight criteria, or rather we're going to define it. And now we're going to hard code the latitude to be 75 and the longitude to be -175. Now we do not know what the current temperature is at the time that this program is being compiled. So we're going to assert that either it's going to be an error, or there's going to be a moderate risk, or a high risk, or a no risk. But that means that our program ran successfully and that we were not met with an error code in our response. Otherwise, it would be an error code, and we would not even get to this part of the program where we are receiving return values, string messages. So guys, that was my program in a nutshell, SKYWATCH version 1. Basically just testing if the flight conditions are favorable or not. And as you can see, everything is running very smoothly here. If we run a PyTest and we run our test, you'll see that in fact, wait for it, everything ran successfully. So that was our final project, and this was CS50 Python, and I'm grateful for having learned this material, and I look forward to building upon it in the subsequent chapter of CS50 SQL and furthermore AI as well down the line in the future. So guys, thank you so much, and looking forward to sharing more projects with you. Okay, bye.